All right, some more skill 14. Let's look at the second example in this section. This is more of the SOH CAH TOA style trig stuff, right? Trying to sort of find different trig values. What's new here, and maybe I should cover this up a little bit so we're not having you try to look at too much information too fast, right? So what's new here is we're not necessarily given all three of the side lengths. I know two of the side lengths. I have sort of a particular angle here, 57. I'm missing what would be the long side. This would sort of obviously be my hypotenuse, right? So that's kind of a mystery value. So what I need to do before I do anything else, because to find these different sine values, I need to know all three of the side lengths. I'm just going to use the Pythagorean theorem to find the missing side. So this is just a throwback to the last skill, to skill 13. Using our Pythagorean theorem, right, our classic a squared plus b squared is c squared. The hypotenuse, the long side, is the c value here. So the two short sides, a and b, are my legs. For the perspective of the Pythagorean theorem, it doesn't really matter which is a and which is b, right? In that formula, they're both playing the same role. So just a quick little version, 10 squared plus 15.4 squared. 10 squared is 100. 15.4 is going to be, I guess it'd be 237.16, because when we add them, we get 337.16. And so then take the root of that to find our c value. That's going to be 18.36. That feels like it could be right. It should be something that's longer than the other two if it's the long side, right? Kind of by definition. So being longer than 15 is a good sign. So from there, all I need to do is sort of just go back and identify, okay, so my hypotenuse, right, is 18.36. The adjacent and the opposite, from the perspective of this 57 degrees, right, the opposite here is the 15.4. The adjacent is going to be this value 10. I'll kind of mark these in here. Right, my opposite. This is my adjacent. And then you can see just setting up the regular sine stuff, the SOH CAH TOA stuff, so just setting up the fractions. So it's just kind of one extra step from what we were just doing. We just need to do Pythagorean theorem to sort of find this extra side length first, right? Get all three of the side lengths going. And then we're all set, right? The sine would be the opposite over the adjacent, so that's the 15.4 over the value that we found, right? The 18.36. So that gets us to a 0.839. The rounding here, I would keep at least maybe 2 decimal places. We've got them to 3 places here in some instances. We've been playing a little fast and loose with our sort of rounding rules. So, why get particular now? Cosine would be the adjacent over the hypotenuse. So my adjacent side is my length 10 over the 15.4. Over the 18.36, right? 15.4 was the opposite. So 10 over that gets us to 0.545. And the third one here, my tangent, TOA, T-O-A, opposite over adjacent. So that's 15.4 over 10 would, of course, be 1.54, right? Dividing by 10. One thing you'll kind of notice with these values, sine and cosine are always going to be less than 1, right? The opposite and the adjacent sides, kind of by definition, will always be shorter than the hypotenuse. So those fractions, those ratios, are always going to be less than 1 because you're always going to have a shorter value over a longer value. Tangent could kind of be anything. It really just depends. You can sort of see up in the last example from the last video, the tangent was 0.75, was also less than 1. But in this case, it's 0.154, right? So it really just depends on the relationship between those two legs. And in some sense, if you take the same triangle and you kind of flip the angle perspective around, well, then you're going to get either sort of a bigger or smaller value, depending on what the positioning is. Let's do one more just from the homework, same kind of idea. So we'll look at number 10 from this set. So this is this triangle here, 52 degrees in the corner, 8.9 and 11.4. Hold on. So if I've sort of redrawn that here, right, the idea is I have, again, the adjacent and the opposite. I'm sort of missing the hypotenuse. So we'll run our Pythagorean theorem. A squared plus b squared is c squared. Right, so 8.9 squared. 11.4 squared. We got those values there in green, 79.21, 129.96. Add them up. So that's going to be our sort of h value squared, right? The h here is our c. So take a root, and that's going to get us, it looks like 14.5. That's where we're sort of in that ballpark. That makes sense, right? Or it seems reasonable. It's bigger than both of the other two values, so that's a good sign. From there, it's just a matter, again, of sort of setting up our ratios, right? Sine is the opposite over the adjacent, so I'm sorry, the opposite over the hypotenuse. Don't talk too fast or else you're going to flip some of these things around. So the sine here is the opposite over the hypotenuse. It doesn't really so matter that this is 52 degrees. We're not really using the 52 in this case. There are ways on a calculator where you can sort of do these calculations. And if you give your calculator 52 degrees and you do a sine value, you're going to get a number. Hopefully it would be 0.79. That would be a good sign. No pun intended. That your calculator's in the right mode and everything is sort of working correctly. But we're just kind of doing the ratios here. We could have just as easily used a theta instead of a 52. We're not necessarily trying to use the 52 here. It's just a different way of showing it. So you can see the three values, sine, cosine, and tangent. So with our three different setups, opposite over hypotenuse, right? 11.4, and then the hypotenuse is the one we found, is the 14.5. So divide it out to 0.79. Cosine would be the adjacent over the hypotenuse, right? So the other side, the other leg, 8.9, divided by the 14.5, so that's a 0.61. And then my tangent of the angle, tangent of 52, opposite over adjacent, the two legs. So that's 11.4 over the 8.9, so that's going to be a 1.28. And that's the setup, right? So that's the basics of this. That kind of tells you how to sort of use these different trig values, sine, cosine, and tangent. These are our big three that we're going to be using for all sorts of different setups in the next couple skills.